So we're going to be taking a look at balancing equations. So we're going to balance the following equation. We're going to balance our hydrogens first. And so in this case, we're going to go through and recognize that we have 6 hydrogens. So in this case, we need to have 6 on the left. That allows us to figure out the number of nitrogens then, and that allows us to go back and figure out the number of oxygens. So in this case, it's going to be a ratio or a fraction. And so the correct answer is D. So write a balanced equation for the combustion of acetaldehyde. So in this case, we know that acetaldehyde plus O2 will form CO2 and water. And so it's easiest to balance the carbon first, then the hydrogen, and then go back and figure out the oxygen, which in this case would be 2.5. Balance the following equation with the smallest whole number coefficients possible. Select the number that is the sum of the coefficients in the balanced equation. So in this case, it's going to be 2 KClO3 goes to 2 KCl plus 3O2. So that number is 7. Write a balanced equation for the combustion of propane. So C3H8 is propane. We know that that's going to form CO2 and water. In this case, we're going to balance our carbons first, then our hydrogens, and then our oxygen. So that gives us C5. What is the total mass of products formed when 6 grams of methane is burned with excess oxygen? So we can figure that out because 1 mole of CH4 is 16 grams. So we can figure out the moles of CO2 and the moles of water that are produced, which is a total of 80 grams. So if we're calculating the mass of hydrogen formed when 25 grams of aluminum reacts with excess hydrochloric acid, we're going to do some dimensional analysis here, where we start with our 25 grams of aluminum, and then we convert to figure out the amount of H2. And so we're going to estimate it's a little bit less than 3, so the answer is D. How many grams of mixed oxide, Fe3O4, form when 6 grams of O2 react with iron, according to the following balanced equation? So again, this is a balanced equation, so we're going to use dimensional analysis, or we could estimate. But in this case, we can calculate that it's approximately 21.7. For the following reaction, 2MnO2 plus 4KOH plus O2 plus Cl2 goes to 2KMnO4 plus 2KCl plus 2H2O. There's 100 grams of each reactant available. Which reagent is the limiting reagent? So we're going to try and find one. So in this case, sometimes it's just a matter of luck which one we try first. So we're going to try the MnO2, and we're going to try the KOH, we're going to try the O2, and then the Cl2. And whichever has the smallest amount, that's going to be our limiting reagent. How many grams of nitric acid, or HNO3, can be prepared from the reaction of 92 grams of NO2 with 36 grams of water? So we have our balanced equation. And again, this is using our dimensional analysis, where we're starting with the NO2, and then we can also calculate with respect to the water to figure out what our limiting reagent is. The reaction of 25 grams of benzene C6H6 with excess HNO3 resulted in 21.4 grams of C6H5NO2. What is the, sorry about that, it's my computer yelling at me. What is the percentage yield? So in this case, our theoretical yield is 25 grams of C6H6 divided by its molecular weight. We use our mole ratio, and then we can determine the amount of product that we would expect. So we know we should be getting 39.4 grams. We got 21.4. So 21.4 divided by 39.4 multiplied by 100 is 54.3%. How many grams of water will be formed when 16 grams of H2 reacts with 16 grams of O2? So we use our balanced equation. Again, we're going to use some dimensional analysis. So 16 grams divided by 32 grams gives us the amount of moles. We have our mole ratio of 2 moles H2O to 1 mole O2. And we know the molecular weight of our water. So that's going to give us, if we estimate, 16 times 2 divided by 32 equals 1 times 18, or approximately 18. When 8 grams of H2 reacts with 32 grams of O2 in an explosion, the final gas mixture will contain. So we can go through and figure out. So we have 2H2 plus O2 goes to water from above. O2 is a limiting reagent, so there's no oxygen left. So B is the correct answer. We have 1.056 grams of metal carbonate containing a metal M were heated to give the metal oxide, and 0.376 grams of carbon dioxide. So this is our balanced equation. What's the identity of the metal? Again, we can use our dimensional analysis to figure out the moles of CO2, and we know the molar mass. So we can figure out the amount of the metal. So 1.056 grams divided by the amount in terms of moles. That's going to give us our molar mass. And we know the molar mass of CO2, so that leaves the molar mass of the metal, in this case copper. So styrene is a building block of polystyrene, which is a hydrocarbon. It's a compound containing only C and H. We're going to take a sample and we burn it completely, and it produces 1.481 grams of CO2 and 0.303 grams of H2O. So we're going to determine the empirical formula of the compound. So if we want to do that, let's take a look at the dimensional analysis that shows that calculation. So this is 14. So I know that I have 1.481 grams of CO2. I can calculate the moles of CO2. And if I have 0.303 grams of water, I can calculate the moles of hydrogen. So in this case, the ratio is 1 to 1. All right. Thanks again for all your hard work and your persistence. Have a great night.